In video 5, we're going to be looking at phase changes and how the temperature of the phase changes works. And then in the next video, we'll actually describe each of the phase changes that we're going to kind of mention here in this video. So a phase change is a reversible physical change. So we mentioned physical changes. We've already talked about those in our first unit at the beginning of the trimester. So this is reversible, and you can go from one state of matter to another. So when a solid goes to a liquid or a liquid goes to a gas, we have these different phase changes. So there are 6 total phase changes. You can see them all here. So you can go from a liquid to a gas. You can also go from a gas to a liquid, gas to solids, solids to gases, and they're all labeled here. We're going to go through each of these descriptions in another video. Just to put them all here on one page, we have melting, freezing, vaporization and condensation, and then sublimation and deposition. And those last two are probably the ones that most people are most unfamiliar with. All right, temperature and phase changes. When you are changing from one state of matter to another, the temperature of your substance doesn't change. That is important. That is definitely a test question. So for example, when ice starts to melt, and so you have maybe a bowl and it has an ice cube in it and it has some water already because it's already started to melt. Well, if you were to take the temperature of that ice cube water mixture there, that you actually are going to have the same temperature the whole entire time where that ice is melting. So that's what I mean when it's actually in the phase change, the temperature doesn't change. Once it's all liquid, then the temperature will start to change as it starts to get to room temperature. So here's the different stages of phase changes. You start at your coldest temperature with a solid. And as your temperature maybe in your room increases, the solid will eventually start to hit its melting point. And then during this time, notice this is a flat line. This means that the temperature is staying at one temperature that whole entire time period while it's a solid liquid mix. Then once it's all liquid, the temperature will start to increase again until it hits its boiling point. At the boiling point, again, notice that when it's in this liquid gas phase, it will also stay at the same temperature, and then eventually when all the liquid has turned to gas, then the temperature can increase as gas. Now, when we look at energy and phase changes, energy is either absorbed or released during a phase change. So either energy is being put into the system or energy is being taken out of the system. And we have a few words to describe that. You may have heard of endothermic and exothermic. Exothermic we'll mention in a few minutes. Endothermic is when you absorb energy from your surroundings. So for example, melting an object. When an object is melting, it's actually taking the energy, the heat around it and absorbing it, and that's causing it to turn into a liquid. So that would be endothermic. Now this is the same kind of triangle that you saw earlier, but I want you to notice that these are specifically marked so that you can see endothermic and exothermic. There are 3 of each. The blue ones here are the exothermic, and the red ones are endothermic. So red representing heat, you have to take heat into you. So again, melting, in order to go from a solid to a liquid, you have to put heat into the system in order to do that. Now if you want to freeze something, if you want to take a liquid and you want to turn it into a solid, you don't want to put heat into it. You want to take heat out of it. You want to take energy out of it. And when you take energy out, that slows the particles down and eventually then they freeze. So every single phase change has one endothermic and one exothermic. Between liquid and gas, you can see there's one of each, and between gas and solid, there's one of each. There are 2 different types of heats that we're going to be looking at. We'll look at one now and we'll look at one in the next video. The first one though is called heat of fusion, and this is the amount of heat that has to be absorbed to go through that first phase change of a solid to a liquid. And the heat of fusion varies from substance to substance. So the amount of heat that water needs to melt from a solid to a liquid is different than the amount of heat that, let's say, copper would need. If you were trying to melt copper wire, you would need a much higher amount of heat and of energy than you would just for water. So the heat of fusion is different depending on what you have. So you can see here this flat line that I mentioned earlier. Again, the temperature is staying the same during that whole entire solid liquid phase change. That is called the heat of fusion. And then the heat of vaporization we'll talk about in the next video, but that's just when you go from liquid to gas. And vaporization, you think about things going into vapor, which is gas. Exothermic, just to finish off this video, this is again when you are going to release energy. I mentioned that with freezing. In order for something to freeze, you need to take energy out of it, and that causes it to cool down enough that it can freeze into a solid. And that's where we're going to stop. In the next video, we'll get through all of the phase changes and some specific definitions for each of those phase changes.